Hello class, welcome to lesson 8-9, which is all about prediction equations. Our new vocab for this section is a line of fit. A line of fit is a straight line that is close to the center of a group of data points. It does not have to touch any of the points. Okay, so some of you might try to draw these lines and make sure that it goes through multiple points, but it just needs to be as close to the center of the group of data points as possible. It doesn't have to touch any of them. So some steps to find the line of fit. The first step is to take the data points and graph them, okay? Once you have graphed those data points, you want to use a ruler. Remember, the rulers are in the bottom drawer of the turn-in bin. Use a ruler to determine where you can draw a straight line so that about half of the data is above the line and half the data is below the line. Okay? Now, let's practice. So if we want to try to find the line of fit, we want to predict the number of students who will take the ACT in 2016. So if I plot these points, I have 2,000 and I have number of students taking it, 1,065. Notice that that's in thousands. So 1,065 is going to be somewhere in there. And then I have 2002, 1,116. 2004, I have 1,171. And 2,102.06. Okay. So then I've plotted the points. Now I'm going to use a ruler to try to draw as many, or to draw a line that goes, tries to cut the data kind of in half. So I'm going to say that my line is roughly going to look like that. I did not use a ruler there because it's really difficult to use them on the smartboard, but I expect you to use it on your paper, okay? And then I want to use this equation to predict the number of students that will take the ACT in 2016. So I go over, I find 2016, I go up, and I see roughly where would that meet my prediction equation. And I end up with about 1,600-ish students will take it, except 1,600, and that's in thousands, so we have to add 3 zeros. So that means 1.6 million students take the ACT approximately in 2016. So step 1, graph the data points. Step 2, use a ruler to try to draw a line that is between about halfway between all of the data points. So now let's look. We want to find the line of fit again. We need to plot our points. So 1999, our percent is 3. 2000, our percent is 7. 2001, our percent is 10. 2002, our percent is 14. 2003, our percent is 17. 2004, our percent is 19. 2005, it's 21. 2006, it is 23. Okay, so that is my data. Now I need to try to find a line of best fit. So if I look at it, I think if I were to try and go through, let's see, I have 1, 2, 3, 4, I have about 8 points. So if I maybe do this, alright, I have about half above and half below. But if you look at it, the points that are halfway or that are above the line are much closer to the line than the points that are below. So I actually want to adjust that because I want this to be kind of in the center. So this time it's a little bit closer. So if I use my orange line, I want to predict the percent of houses that do not have landline phones in 2016. So I go up 2016. I'm going to predict roughly about 40-ish% do not have landlines in 2016. So I'd say about 40%. The two squiggles, that means about or approximately, okay? So what if we want to write the equation for the line of fit? We pick 2 points, find the slope, write the equation in point-slope form. Let's quickly review what that is. Point-slope form is y minus y1 equals slope times x minus x1. And then you want to use the equation of the line to predict the outcomes and answer questions. Also, in case you forgot what slope is, there's a quick reminder. Okay, so step 1, find 2 points, or pick 2 points, find the slope. Step 2, write the equation in point-slope form. Step 3, use the equation of the line to predict outcomes and answer the questions. Okay, so let's look at what that would look like. If we have this movie theater screens example, we have number of screens on our y-axis and years since 1999 on our x-axis. We want to predict the number of movie theater screens in 2016. So what we're going to do is they've already highlighted 2 points for us. So I'm just going to use those. So my first step, find the slope. So y2, so 38, minus y1, 37, over x2, which is 6, minus x1, which is 2, so I have 1 over 4 as my slope. My next step was to write it in point-slope form. So I have y minus, I'm just going to use the first point, so 37 equals 1/4 x minus 2. Alright, now it's not easy to use an equation in point-slope form, so why don't we switch that to slope-intercept form, so that way we can plug numbers in more easily. So we have y minus 37 equals, I'm going to get rid of those parentheses by distributing the 1/4, so I have 1/4 x minus 1/2. And then I need to get y by itself, so I'm going to add 37, add 37. So I have y equals 1/4 x plus 36.5. Alright, my last step is going to be trying to figure out how many screens exist in 2016. So what I'm going to do, I say y equals 1/4, and then here we have years since 1999. So how many years since 1999 would be 16 plus 36.5. So we have 1/4 times 16 is 4 plus 36.5. Or we know that there will be about 40.5 . Oh, yeah, sorry. I did the wrong number. Okay. If I did years since 1999 and I selected 16, this tells me all about 2015, right? Because it is 16 years from 1999 to 2015. I'm sorry about that, guys. But, so in order to find 2016, I would just plug 17 in there, okay? So I'm not going to go back and redo that, but my answer would be 40,500 movie screens in, and then this would be 2015. Okay? So step 1, find the slope. Step 2, write it in point-slope form. Step 3, switch it to slope-intercept form, the y equals mx plus b. Step 4 is to plug your data, in to the equation you came up with. Okay. Let's look at writing an equation for predicting the winning time in the 2016 Olympics. So we have a couple of points that are on the line. You always want to choose spots that are on the line, okay? So if I look this point right here, that's nice because it lines up with both an x and a y. So this is 24:53. And my other one right here also lines up nicely. It's 36:52. So step 1, find my slope. So I have 52 minus 53 over 36 minus 24. That ends up being a negative 1/12 is my slope. I plug this information in. I have y minus 52 equals negative 1/12 times 36. Oh, sorry, x minus 36. All right, and then I want to solve that. So I have y minus 52. I want to solve it to get it to a slope-intercept form. I have to distribute my slope in order to get rid of the parentheses. So I have negative 1/12 x. And then negative 1/12 times the negative 36 becomes plus 3. Then I just have to add 52 to both sides. I have y equals negative 1/12 x plus 55. Now, if I want to figure out how predict the winning time in the 2016 Olympics, I have to look. It's years since 1964. So years since 1964. I do 2016 minus 1964, and I get 52. So I plug this information in. So I have y equals negative 1/12, and then instead of x, I'm going to say 52 plus 55. That's the equation I had. So y equals negative 4.33 plus 55. So the winning time should be about 50.66 seconds. Alright, so make sure you have written down that process because you're going to have to do that on your assignment. It's on page 450. You have to do problems 1, 2, 3, and 4, and you need to make sure that you graph 1A, 3A, and 3C. Alright, I hope you guys have a fantastic day.